Alright, good day everyone. Alright, so we are on this topic of sorts. So previously, as a recap, we have covered the solubility of the sorts. Okay, so let's have a look again before we go into the different salt preparation techniques. Alright, so on the soluble salt side, we have our group 1 ammonium as well as nitrate salts. More commonly from group 1 you deal with sodium and potassium, so sometimes I will call them the span salts, if I would like. Alright, okay, the next group will be the halides. Okay, so halide actually come from group 17. Okay, they are actually your group 17 ions, okay, such as chloride, bromide, iodide. Most of them are soluble except for the LS halide. That means your lead 2 and silver are. Alright, not your lost eye. Okay, although I use it to remember this LS. Okay, next thing is all sulfates are soluble. Insoluble ones includes calcium, lead, as well as your barium. Okay, so your CLB are the insoluble ones. Okay, very coincidentally, all is 2 plus, Ca 2 plus, Pb 2 plus, Ba 2 plus. Alright, next group we have the carbonates, which are majority insoluble. So the soluble ones are your group 1 as well as ammonium. Okay, 1A, okay, which is sometimes I will call them the spa carbonates, which kind of overlaps with your span salts already. Okay, and then the next category, actually I don't exactly call them salts. Okay, they are your oxides and hydroxides. So basically they are bases. Alright, most of them are insoluble except for your group 1BC. Okay, barium and calcium. Okay, so based on that, we shall look at the next exercises, which I think you have done before. Okay, so the first thing that I will do is definitely to look for nitrate. The span ones lah, basically. Those with nitrate, sodium, what else? Yeah. Alright, so the span salts are basically definitely soluble. Okay, alright, so the next one, then we look individually. Okay, let's start from zinc chloride. Okay, zinc chloride, okay, it's not L lead, neither is your silver, not an LS, so definitely soluble. Okay, next one we have your iodide, another halide. So this time you have the S of the LS, so it's definitely insoluble. Okay, another halide, but this time around again not LS, so it's definitely soluble. Then we go into sulfates. Okay, so this is part of your CLB, the C. So this one is sorry, right on the wrong row, goodness. Okay, so CLB, so your C, which is your calcium, so definitely insoluble. Okay, then another nitrate I have, so definitely soluble. Missed that out just now. Alright, okay, then you have iron 2 carbonate. So this is not your group 1, neither is it your ammonium. So this one definitely insoluble. Okay, next thing we have copper 2 sulfate, but it's not the C of the CLB, not calcium. So this one is soluble. Okay, then iron 2 chloride, not lead, not silver. So it's soluble for sure. Then you have zinc oxide. Okay, so zinc oxide, this one is not your 1BC, not group 1, not barium, not calcium. So definitely insoluble. Okay, then the next thing is aluminium hydroxides. Okay, so this one also again not 1BC. Alright, so definitely insoluble. Likewise for the next one, also not 1BC. Okay, then we have the L, okay, for halide, lead. So this one insoluble. And then I have the B of the CLB for this sulfate, so it's insoluble as well. Alright, very well. Let me look at the next one. Okay, just a moment. Okay, there are several methods to prepare the salts, okay, and are decided based on the solubility of the salts needed to be prepared. Okay, so we are going to look at three methods in total. Okay, just one for insoluble salts. Alright, okay, which is going to be the first method that we are going to look at. Okay, it's called precipitation method. Okay, the only one for insoluble salt. Okay, so the key idea here is you are going to start with two solutions. Okay, so precipitate is a term that not used to describe raining lah, huh? Okay, is something that we use to describe an insoluble salt. Alright, okay, then you start with two solutions. So this is the first method that I'll look at. Okay, so the idea, okay, for example, let's say I want to prepare something like silver chloride, okay, the S of the LS chloride. Okay, so two solution, one is nitrate, and then the second one can be an acid or a spa salt. Okay, so remember the first one, your metal, your cation always pairs it with the nitrate. So the first solution you use is your silver nitrate. Second one is your chloride. Okay, so this one can be an acid, okay, which in this case is hydrochloric acid, or otherwise a spa salt. Okay, so we got a couple options for the chloride. So you can have sodium chloride. Okay, I just show you as one example now. Otherwise potassium chloride. Okay, then what else you can? Ammonium chloride also possible. Okay, last but not least, of course, you can actually use your dilute hydrochloric acid. Alright, okay, right, okay, so example, let's say you decided to choose sodium chloride. Okay, the other product that you get, but that's not the most important it's a byproduct, okay, is sodium nitrate. Okay, so let's have a look okay, at more examples under precipitation. Okay, later on when we look at the second and third method, okay, adding excess, I'll come back to this page again. Alright, so allow me to toggle around. Okay, so the first method I'm going to look at is precipitation. Okay, then later on, of course, before I talk about the technique itself, I'll show you a video. Okay, but now let's see okay, so in this part of the unit, what we are going to do is I'm going to give you a name of a salt. Okay, so you have to work backwards to tell me what you come up with. Okay, as in what you need to prepare that salt. Okay, so there are quite a few examples. Okay, so wait let me see okay, never mind, I shall use this page Okay, hang on Okay, so it's this method is suitable for preparing insoluble salts. Okay, so you need two solutions, one containing anion, the other one containing the cation. So the cation one always goes with is a nitrate solution. The anion one is always spa, sodium, potassium, ammonium, or otherwise an acid. Okay, so the idea is this: you add two solutions together, you get an insoluble salt. Alright, okay, for example, another example I give you is lead 2 sulfate. Okay, so the lead the first word actually goes with the nitrate. Okay, so the one containing a cation it will be the nitrate solution. Sulfate go with either the spa or the acid. So be able to see this pattern is important. Okay, ammonium sulfate. Another option that you might have here is you can use sulfuric acid. Alright, okay, then next thing, I think did I show you silver chloride? Yes, that was the one I showed you earlier on the previous page. Then you have silver nitrate, or sodium, potassium, or ammonium chloride. or otherwise hydrochloric acid. Okay, let's take a look at the first example. So barium sulfate okay, your barium definitely go with your nitrate. Then your sulfate is either a spar or otherwise sulfuric acid okay. So all these are actually all insoluble can just go on to put a sign like this okay, all of them are insoluble okay. Method that you use is definitely precipitation. Okay, so later on when I jumble out everything okay, then it's harder okay, because now I go method by method, it's quite clear cut. Okay, next one you have lead 2 chloride. Okay, so your chloride you go with a spar or otherwise an acid, okay, which is hydrochloric acid okay. Then your lead will go with nitrate okay. So that's why you have, okay, it'll be good you can add the word aqueous as well okay, in all these solution, aqueous lead 2 nitrate. And then whenever you write acid, it'll be good you can add in the word dilute. All right, dilute hydrochloric acid, aqueous sodium chloride, aqueous potassium wait goodness, I make a very bad typo. Okay, I must change. Okay, aqueous ammonium chloride Okay, next one we have copper 2 carbonate. Okay, so the carbonate can go with a spar salt or actually acid if you know, carbonic acid okay. Then copper 2 can go with nitrate of course. You want to do copper 2 sulfate as long as it's a solution okay. What I'm proposing here is like a foolproof way definitely. Yeah, you won't go wrong because span salts are definitely soluble okay. So safest is go to sand salt if you have an option all right. Okay, so you have dilute carbonic acid, aqueous sodium carbonate, or aqueous potassium carbonate. Or aqueous ammonium carbonate even. Right, then you have iron 2 hydroxide. Okay, okay, in this case you can use sodium potassium, but you cannot use A because there's no such thing as ammonium hydroxide okay. So this case iron 2 you can go in nitrate as always okay. So this one number 1 is aqueous iron 2 nitrate. Number 2, the second thing you go with aqueous sodium hydroxide. And aqueous potassium hydroxide. Okay, right. But do not write this one ammonium hydroxide do not there's no such thing. Okay, there's no such thing okay. Then we are done okay, with the possible starting reagents. Okay, so now let's look at the techniques itself. Always easier to remember with pictures okay, but let me show you a video first of this method. Okay, we are going to do practical on salt prep lah. Okay, just to let you have a feel. Okay, I hope the video can play. If not, I have to go into YouTube. Okay. Let me go back again. So he's trying to add lead-2 nitrate to potassium iodide. So this case, think about what kind of salt that he's trying to prepare. He's actually trying to prepare lead-2 iodide, which is the yellow color precipitate that you see. It looks like paint, but it's actually a yellow solid. Okay, so you just add lead-2 nitrate to potassium iodide, and then the yellow precipitate. Is filter out the yellow precipitate. Filter out, you wash the precipitate with distilled water. And lastly, pat dry between pieces of filter paper. Alright, okay. Yeah. Okay, let me go back to the notes. Okay, so in the example used in my note is barium sulfate. So barium go with nitrate. Okay, then the sulfate can be a spar or otherwise an acid, sulfuric acid. Okay, this case I think I chose to go with sodium. Right, so you add the two solution together, aqueous sodium sulfate to aqueous barium nitrate. Then you get a white color precipitate. Okay, so next chapter we're going to learn a bit about colors of precipitate and different solutions. Okay, then you form your barium sulfate, which is what you want. Okay, then you filter. Next thing is filter to remove. So now you want what's inside here, the residue, barium sulfate. Okay, then next thing, wash the precipitate with cold distilled water, or otherwise distilled water can already. Okay, you can cancel away the word cold. Alright, and then next thing, pat dry between two pieces of filter paper. Alright, okay, I hope you get all the points. Alright, it's a pretty short technique, okay, compared to the next two. Okay, so next one is adding excess insoluble reactants. Okay, okay, let me go back to this page, page 23. Okay, so adding excess insoluble reactant to acid. So what is that insoluble reactant? There are a couple of them. Okay, solid reactants. So you make use of the acid reaction. Can be a metal, can be an insoluble metal carbonate, otherwise an insoluble base. Okay, of course, I hope you know what's a base. It's either an oxide or a hydroxide. Okay, so this makes use of reactions of acid. So acid plus base gives you salt plus water. Okay, then carbonate plus acid gives you carbon dioxide, then plus salt plus water. So these are actually all reactions of acids which you have learned before in the previous chapter. So this gives you your salt plus hydrogen. Okay, but only reactive ones things like copper cannot. Alright, so we're going to look at this method which majority of the soluble salts are prepared by this. Okay, so example I give you. Okay, so because the other group is only applicable for spa salts okay, sodium, potassium, ammonium. Okay, so those non-spa one, usually non-spa soluble salts usually prepared by this method. Okay, I give you one example Okay, let's say you want something like zinc sulfate. Let's say. Okay, so the second word will always help to tell you which kind of acid you can start with. Then this kind helps you to see which kind of base, metal, if it's applicable, or carbonate you start with. Okay, so this case sulfate. Okay, I'm going to start with sulfuric acid. Certainly sulfate salt always start with sulfuric acid. Okay, next one you have zinc metal, possible because it's reactive. Okay, then you can have zinc carbonate, zinc hydroxide, or otherwise zinc oxide Okay, can. So let's go into the method itself. Okay, so this kind of adding excess solid reactants to acid is usually for soluble salts that are not spa salts okay, soluble but not spa ones that means not sodium, potassium, ammonium. Okay, not group 1 and ammonium. So you make use of all these solid reactant metal, insoluble base, insoluble carbonate. Okay, so one thing to note is that the solid we say add excess solid, right? Okay, how come not excess acid? Okay, reason is this you must know okay, it's important it's so that to ensure all the acid is reacted so that the salt is not contaminated with acid. So in a chemical reaction, not everything you add in will become the product. Okay, I give you an analogy to illustrate this point. Okay, let's say two bread this is a bread what I'm drawing here is two breads and plus one ham. Okay, then it gives you a sandwich okay, so if you have an extra bread, okay, then this is excess, right? This piece of bread is actually excess. Okay, you still make one sandwich only. Alright, so the idea is like that okay, you want to make sure the solid is in excess so that you can very easily get rid of it okay, and not the acid, because the acid is a solution, then your salt is also a solution, you see. Okay, the insoluble ones, okay, can be filtered from the salt solution at the end. Okay, so let's have a look right. Okay, so example, only two example. Okay, so for example, you want to prepare zinc sulfate okay, this one, okay, will tell you about the metal, the base, or the carbonate Okay, so base is oxide or hydroxide. Carbonate, of course, we have the word carbonate. Then this one is the tells you about the acid. Okay, so you notice if it's a sulfate salt, sulfuric acid, chloride salt, hydrochloric acid, nitrate salt, nitric acid. Usually you deal with this three kinds of acid. Alright. Okay, then next thing, maybe I use a different color. Zinc. Okay, you can use zinc metal, zinc oxide, zinc hydroxide, or zinc carbonate. Iron 2, then you either iron metal. There's for the metal you don't write iron 2 iron 2 oxide, iron 2 hydroxide, or iron 2 carbonate. Right. For copper, a bit special. You cannot use copper metal. You start with the base or the copper 2 carbonate. Right. Okay, so you're down by one option for copper. Okay, this is because copper is an unreactive metal. If you look back, copper doesn't react with acid, right? Okay, so for all these they are soluble Then the method you use is adding excess solid reactant to acid. Alright. Okay, so this one tells you about the acid. So you have to use hydrochloric acid. Copper 2 sulfate means you have to use sulfuric acid in this case. Okay, then this one tells you about the metal, the base, or even the carbonate. Okay, so let's have a look. So it is chloride salt, hydrochloric acid, sulfate salt, sulfuric acid. Okay, next thing, magnesium can be magnesium metal, magnesium oxide, magnesium hydroxide. These two are bases, or otherwise magnesium carbonate. All will come out with the salt. Okay, copper a bit more special. No copper metal, but you can copper 2 oxide, copper 2 hydroxide, or even copper 2 carbonate. Just down by one option. Okay, then next thing we are going to look at is a couple of steps and why we do them. Okay, so before that, I'll let you watch the video of preparing copper 2 sulfate first. Hang on. Okay, any excess. Alright, okay. Prepare the copper 2 sulfate. Okay, you will just keep adding the solid to the acid. Okay, it's a black color solid copper 2 oxide. Okay, then you just add until no more can dissolve. Okay, then you know it's in excess already. That's what it's trying to do. Okay, and you can see if you pause slightly and have a look at it, there's like some condensation by the side. Okay, means this acid is actually warm one. Okay, later think about why it need to be warm. Okay, so once it excess, right, okay, you will have to filter out the excess solid. Okay, so what you want is the filtrate itself. Okay, then next thing you do is you heat to saturation. That means about 1/3 of the original volume. Saturation, later I explain what it means. Means maximum concentration. Then you put the crystals to let it form. Then you filter one more time. Right, okay, let me go back to here. Okay, so next thing, okay, so the first thing you do is this. Alright, okay, so you add excess zinc powder. Okay, so this one they want to prepare zinc sulfate so that's why I use sulfuric acid then they use the metal option Alright, okay, so what they do was add excess zinc powder. You must make sure it's zinc powder into warm dilute sulfuric acid. Okay, why must be excess? Okay, excess because to ensure all the acid has reacted, so salt is not contaminated with acid. Okay, and why you use powder? You don't use one big lump. It's because powder actually reacts more quickly, and then likewise, okay, when you warm the acid, it helps to speed up the reaction as the temperature is higher, reactions go faster. Okay, next thing, okay, after you add everything you need to do a filtration. The excess zinc will be here. You got to do a filtration. So this is what you want. The zinc sulfate is here. Alright, so filter to remove excess zinc. Okay, then you want to filtrate okay, and then you heat the zinc sulfate solution to saturation. Okay, another way you can write is you can just write like that. Heat the zinc sulfate solution to saturation. Okay, saturation usually what it means is 1/3 of the original volume, half to 1/3 Okay, in such a way this method usually works if the salt is more soluble in high temperature than is in cold temperature. Meaning to say, it looks something like this. If you want to have a solubility curve, this one I just explaining to you how the solubility of the salt should change with temperature. Okay, ideally in the crystallization, you are doing crystallization. Okay, so let's say okay, at like 80 degrees Celsius versus 30 degrees Celsius, you have 50 grams that can dissolve. Then at 80 you have 100 grams. Okay, then you let it cool down. Okay, you notice there will be 50 grams that will crystallize out Alright, so usually for this method the salt, right, must be more soluble. Okay, at high temperature. Okay, then in Alright, so heat the filtrate to obtain saturated zinc sulfate solution. Okay, so or otherwise I say heat the zinc sulfate solution to saturation. Okay, so that means maximum concentration. That means you dissolve until cannot dissolve. Okay, so that when it cools down, you're trying to vaporize off some of the water, which is the solvent. Okay, so when it cools down, then a certain amount will actually crystallize out. Right? Okay, then you let the hot saturated solution cool and crystallize, and finally filter to obtain the crystals. So this one you need to do one more time, the filtration with the crystals. Okay, then you do one more time. Okay, so this time round the crystals is what you want. Okay, then final thing, okay, wash with cold distilled water, pat dry with pieces of filter paper. Okay, so now let's look at some questions, okay, or examples, okay, to check your own understanding lah. Okay, so let's take a look at question 13. So a practical book gives the following instructions, okay, for preparing crystals of hydrated zinc sulfate. Okay, so first thing, place 100 centimeter cube of dilute sulfuric acid in a beaker. Heat the acid until it's almost boiling. Then you add zinc powder bit by bit until no more dissolves, and then you filter the mixture. And step number 4, place filtrate in evaporating dish. Place the evaporating dish on a tripod and heat until the solution has been reduced to half its volume. Put the filtrate aside to allow it to cool. Then you filter off the crystals from the cold solution and dry them on a filter paper. Do not heat the zinc sulfate crystals. Okay, so now we need to explain why they do certain things. So explain why zinc oxide powder is added until no more dissolve. The reason is so that you ensure all the sulfuric acid has been used up. The salt no longer contains any acidic impurity. Okay, then you can just filter out the zinc oxide powder lah. Okay, next thing, how come the reaction mixture needs to be filtered? To remove your excess zinc oxide as residue from your zinc sulfate. Okay, and then part C, explain why, okay, the solution in the evaporating dish needs to be heated to half its original volume. Okay, so what you're trying to do is vaporize off some water so that the solution can be saturated. So upon cooling, then you will see crystals of your zinc sulfate. Okay, then next thing, okay, I have next thing, okay, I need to change the next part. Okay, change it to why do not heat the zinc sulfate crystals. Okay, so that you do not decompose the crystals. Okay, so sometimes okay, let me tell you, since we're on this, sometimes you may see formula like this, dot 5H2O. So that means this one is hydrated. Crystals. Okay, that means they have this part, which is what we call the water of crystallization. Okay, so then this way, then once you heat it will become anhydrous. Okay, so anhydrous means without the water of crystallization. Okay, dot 5H2O come out as water vapor. Okay, can I show you an example of the copper 2 sulfate. Okay, this one. Okay, so you have this one, the hydrated one and the anhydrous one. Okay, the real one of course look like this. white one is anhydrous, blue one is hydrated. Okay, right. Okay, next thing is next thing is interesting. Okay, describe how lactose sulfate can be prepared from lactose oxide. Lactose sulfate is actually an insoluble salt, which if you base on what you learned earlier, you must start from two solutions, right? Okay, two solutions are over here. Okay, but lactose oxide is actually insoluble. Okay, this is actually a solid. Okay, so how? Okay, don't worry. Okay, step by step first. So first thing we do is figure out what are the two solutions you need to prepare lactose sulfate. Okay, remember this one, the first one goes with nitrate. The second one goes with either the spar or the acid. Okay, so you have your sulfuric acid, then plus your lactose oxide. You have your lactose hydroxide. You have your lactose carbonate. Alright, wait, what am I doing? Sorry. No, wrong. My apologies. Okay, should be lactose nitrate only. Okay, lactose nitrate. Okay, or otherwise sulfuric acid, sodium sulfate, potassium sulfate. Okay. Alright. Okay, but now the problem is this. You must start with lactose oxide. So you break into two parts. Okay, the first part will be trying to create lactose nitrate, which is actually a soluble salt. Okay, so what you have to do, you use the adding excess method. So it's a hybrid of adding excess and precipitation method. So this is very unique. Okay, so down here, okay, this one tells you about the acid, right? Okay, so first part I'm using adding excess. Okay, second part I'm using precipitation. Okay, so you have nitric acid. Okay. Okay, so you add excess lactose oxide to dilute nitric acid. Then you filter to remove the excess lactose oxide as the residue, and then aqueous lactose nitrate as the filtrate. Okay, so so these two parts is adding the adding excess part. Okay, the adding excess part. Okay, then subsequently you have, okay, then you prepare your lactose nitrate. Then subsequently is the precipitation part. Okay. Okay. So what you do next is add aqueous sodium sulfate or dilute sulfuric acid to aqueous lactose nitrate that you prepared earlier on. Then you filter to remove the lactose sulfate precipitate as residue. Wash the precipitate with distilled water and then pat dry between pieces of filter paper. Okay, then I have 15 16 okay, 15 16 okay. So lead 2 chloride is a salt which can be prepared by the precipitation method. Okay, so name the suitable reagents for the preparation of your lead 2 chloride okay. So okay, same thing precipitation so the cation goes with the nitrate then chloride goes with either spar or the acid okay. So this case you can use lead 2 nitrate, dilute hydrochloric acid, sodium chloride, potassium chloride, there's even aqueous, ammonium chloride. Okay. Okay, then next thing, explain why your precipitation method is suitable for the preparation of your lead 2 chloride okay. So why is it suitable is because lead 2 chloride itself is insoluble. Then you are using two solutions, say lead 2 nitrate and then for example sodium chloride. Okay, so this one is your solution, this is also your solution, then you have your precipitate, okay, lead 2 chloride. Okay, of course there will be a byproduct called sodium nitrate. Okay, so this one is your precipitate Alright. Okay, so to explain it, okay, you say that your lead 2 chloride is insoluble, the reactants and the byproduct are soluble. Hence, precipitation is suitable as your lead 2 chloride can be formed as a precipitate which you can easily remove by filtration. Okay. Then question 16 is name 2 aqueous solution to prepare your silver chloride. Once again, insoluble salt, so silver goes with nitrate, and then chloride goes with your spar or otherwise an acid. Okay, so aqueous silver nitrate, aqueous sodium chloride, dilute hydrochloric acid. Okay, other possibilities includes aqueous potassium chloride, aqueous ammonium chloride. Okay. Then write an ionic equation including state symbols for the reaction in A. Alright. So this case, okay, let's say we choose sodium chloride Okay. Okay. So basically is this way silver nitrate plus sodium chloride. Okay, gives you sodium nitrate plus silver chloride okay. So this is Ag plus, nitrate is NO3 minus, sodium Na plus, chloride Cl minus, sodium Na plus, NO3 minus. This is silver is always plus 1 although it's not in group 1 okay. Then all is 1 1 so AgNO3 plus NaCl gives you NaNO3 plus AgCl. Okay, wait. Okay, so aqueous, because it's nitrate, sodium salt aqueous, sodium salt aqueous, then this one is the solid. Okay, then for the ionic equation, you break this, okay, this one leave it. So basically what you have, you go back to like the previous step lah. Okay, wait. And plus AgCl. Okay. Right, and then of course the silver chloride is for observation. It's a white precipitate lah. Alright.